Settle down. Thank you, Zoe. I appreciate the warm welcome. And good morning, everyone. According to the teleprompter, I am Derek Molnar, and I am a territory manager with Degelman Industries, and I am joined today with Jordan Heimlich. He is a engineering training and a procast designer. Degelman Industries has been engineering tough, high-performance equipment for 60 years. And we are excited to stand on the launchpad stage here today at Canada's Farm Show to introduce one of our newest products, the Procast Precision Granular Applicator. The Degelman Procast is the world's first precision granular applicator designed specifically for Degelman Pro-Till high-performance discs and our Strawmaster series of heavy harrows. Whether you're seeding or applying granular herbicides, the Degelman Procast is designed to deliver an accurate spread of product in any kind of field conditions. The Procast includes state-of-the-art features including a non-pressurized tank, isobus controls, and a simple, accurate metering system that is designed to make granular application and cover crop seeding safer and more efficient than ever. Before we get into more detail on what sets the Procast apart from everyone else and other granular applicators, let's take a quick look at some of these key features. The Procast is an isobus machine and requires a UT to function. Most farmers have isobus capability in their tractors, so it is important for the Procast to work in tandem with the customer's monitor and not require an additional setup. For customers without an isobus capable tractor, a monitor is required. For example, a Trimble GFX 750, Raven Viper 4, Raven CR12, and Raven CR7. Compared to many broadcast applicators, the Procast uses a distribution tower to divide product into their runs. Our distribution manifold allows for even distribution of product across the entire machine. This is key as implements continue to get much larger. Did I skip one there? Just as I practiced. We are always interested in making things simple for the end user. The Procast features an easily adjustable metering system to achieve a wide range of results. In addition, calibrating the unit is done in just a few short steps. Jordan is going to go into much more detail and depth on these features shortly. The Procast is a variable rate machine. In addition to that, Trimble's isobus software enables sectional control for the Procast. This capability is being developed for the Procast 120 with production targeted for this fall. The current Procast 80 model is capable of single section on-off and will have limited sectional control options to follow. Now, while we won't recommend parting with your air drill anytime soon, the Procast is a great backup plan when you need to seed in adverse conditions. Paired with a Pro-Till, you will give yourself the opportunity to seed where air seeders can't. And in addition to the Pro-Till, combining a Procast with one of our Strawmaster Pluses, Strawmaster X's, or Strawmaster series of harrows, field preparation passes can be enhanced with the Procast by applying granular herbicides at the same time. "60 years ago, Wilf Degelman developed the first Degelman reel-type rock picker with one idea in mind: build it right, build it heavy, and build it to last. We always keep that in mind when we develop products, and that's why you're going to see things on the Procast like a durable steel tank, a Parker fan motor, an easy access ladder, and lots more. I am now going to hand the keys over to Jordan to get into much more detail on the design intent and the process that went into developing the Procast, as well as run through the ease of setup and some testing results.
Thank you, Derek. Like Derek said, my name is Jordan Heimlich. I've been a Procast designer for the past 2.5 years with Degelman's R&D department. I'd like to take a step back from the features and how Derek has laid this out and just talk about the motivation of the project, some of our design goals, walk through a quick start, show you how easy this machine is to set up, and then get into some of our results and testing. So let's start with motivation. Our lack of a dedicated pneumatic seeding machine or a broadcast seeder has kind of put us at a disadvantage compared to other options in the marketplace. if a farmer or a producer is looking for a machine with a compatible seeder, we wanted to be able to provide that. And that kind of forms the underlying motivation or basis for this project. And we also felt that farmers needed or deserved additional options that other pneumatic seeders didn't have. We wanted to ensure that our product was meeting precision and accuracy of other machines in the market. And we wanted to reduce our reliance on third-party suppliers to provide our customers with the equipment when they needed it. But most importantly, we wanted to design a machine that was specifically built around our implements and to maximize their effectiveness. I'm just going to walk through some of the design goals that we set about at the beginning of this project. A bit of a repetition here, but bear with me. We wanted the ProCast to fit on all of our ProTills 30 feet and higher, as well as all of our StrawMaster machines. So that includes the 7000s, the SM Plus, StrawMaster X, and the SM Pros. We wanted to maximize the tank size. Basically, we're trying to install this machine on a ProTill, and given the transport restrictions and the space envelope inside, we wanted to maximize that space so that our farmers could keep running longer in the field. We wanted to make sure this machine was easy to use, and so that's kind of where we'll talk about our control system a little bit more. And we also wanted to make sure that we had a highly versatile metering system that could handle a broad range of products and rates. We wanted to make sure it was easy to calibrate so that our farmers could get in the field faster. And we wanted to make sure that we were meeting an industry benchmark on accuracy and precision. So from the beginning, Degelman does not have any experience designing or producing a pneumatic applicator, and we knew that expertise in this field would come in, be a very valuable asset. So we approached a company called Seed to Soil at a trade show much like this one. Seed to Soil is a German-based consulting company that specializes in agricultural engineering, and as the name suggests, has a strong background in seeding technologies. We've since developed a strong relationship with the team you see on the screen here. These guys deserve a lot of credit, and they've guided us through many of the early design decisions, the prototyping process, and have suggested many improvements to our machine as the project has gone along. So I'm just going to take a moment now and just kind of go over some of the features that Derek's already mentioned in a little bit more detail. So like I've already stated, one of the goals of our product was to maximize the tank size, and we also wanted to fit on everything from a ProTill 30 and up. So that automatically makes our ProTill 30 the smallest space envelope that we have to work with. So the tank was spatially designed within the constraints of a ProTill 30. As you can see, it's quite a bit taller. We're limited by how our metering system operates, that we have to be able to get access underneath. But in addition to the tank design or our space constraints, I'd like to point out a few more considerations. One, a steel tank is robust, durable, and easily repaired. And it's also easier to manufacture and modify according to the space constraints that we had. Another one is that our fabricating a tank out of steel allows us to mount additional options or features to the tank itself without the need for a secondary structure. So as you can see on the machine to your left, we've got a side door that swings out, platform folds down, ladder so you can reach the lid on the top, and we can also mount all of our primary tower and fan directly to the tank on the front. And lastly, we spend a lot of time testing for different product angle of repose, trying to make sure that all of our products will feed the meter without, collecting on the sides of the tank. Next, I'm just going to expand a little bit on the metering system. Our metering system does provide a broad range of capabilities with product range and the ability to do different products. We achieve this by engaging or disengaging rollers. The way our machine works is it dumps all of the product into a 5-inch Airstream, and then it gets split later down the road with our primary tower, which I'll get to in a sec. But that allows us to essentially just change the amount of product that's going into that Airstream at the meter box. So by engaging or disengaging rollers with the set screws that you can see there in the middle, we can just change the volume that each rotation has. In addition, we've done plenty of testing with this meter now, and we found good results, and I'll go over those results in a minute here, but with wheat, cereal crops, radish, canola even, cover crop mixtures, and granular chemical. I'm going to discuss a bit more in a quick start on how to set up this meter, and we'll come back to it. So our pneumatic system. Our fan is sized to operate with our largest machine, the StrawMaster Pro 120 foot. As you can see here, it's just showing a schematic of how the air works. It comes from the front of the machine through the tank. There's a tube that goes through the tank, transfers the air to the back, comes back around through the metering system, and then up through the distribution tower. That distribution tower is what makes the Procast a little bit more unique compared to existing broadcast seeders. Most broadcast seeders will seed directly into the hoses. So that allows us to have the metering system that we do and improves our ability to get a broad range of rates with the same rollers. And I will next move into our control system. So early on in this project, there was a lot of discussion about what we were going to do with our control system, whether we would build our own with a dedicated monitor. But in the end, we decided to go with Trimble. And as a leader in isobus systems, we are able to present to you today a plug-and-play machine. So any tractor with a UT unlocked and isobus capability will be able to see the control screen that you can see there. What that also allows us to do is we can provide a secondary, a third market aftermarket monitor from Raven, Trimble, anything that's isobus compatible. And with using that technology a little bit further to its full extent, we can offer sectional control capabilities, prescriptions, and data logging. I should point out here that like Derek said, with the Procast 80, we don't have sectional control at this time, but it is very useful for auto on-off. You can set up your machine as one section, and then you don't really have to play around with it as you're seeding in the field or applying product. I'm just going to discuss tractor requirements briefly. So like we've already covered a couple times, you do require an isobus monitor. So that's your control system. That's how you're going to be able to operate the machine. This machine uses one hydraulic circuit, uses 3/4 inch or -12 couplers. There's -8 couplers in the toolbox for an adapter if you need. Also uses a K-strain to relieve back pressure on the fan, which is a flat face coupler. Moving on, I'm just going to discuss the distribution system. So we've kind of discussed the tank a little bit, and now we're trying to worry on how to get that product from the distribution head to the ground. And so what I'd like to point out here is that all of our distribution systems are tailored specifically to the class of machine they're on. Every machine is a bit different and has different pinch points. So we've designed our hosing brackets and routing systems to accommodate that, get the hoses safely to their drop points, and deliver product in an efficient manner. You can see on here, this is a ProTill 41 center frame as it comes into from the hitch into the center frame and then out towards the wings. Then as a ProTill folds into transport, obviously we got to worry about pinching our hoses in the wings. I guess the one thing I'll point out here is that ProTill uses a distribution head with 18 hoses and 1.25 inch hose, which is a little bit different compared to our StrawMaster distribution systems that use an 1.5 inch diameter, inner diameter hose, and has a bit more involved with this machine. Given the wide width of the StrawMaster, we have to increase the number of drop points so we have an even spread across the ground. So we've developed our own Y-splitter technology. You can kind of make them out there on the frame. They're mounted to the spring bars, and then the product drops in front of the harrows for adequate incorporation of granular chemical. So now I'm going to walk through a quick start just to kind of demonstrate how easy this machine is to get running. On the screen right now you can see 2 decals that are included with the machine, or they're also in the back of the manual. And it's basically going to tell you how to set up your meter. So like I said, we're engaging or disengaging rollers to achieve the correct volume that we're dumping on every rotation. And that kind of confines, you want to use the correct rate or range so that we can keep our meter rolling between 45 RPM and 90. Too high, you have more wear issues over time, and then too low, and you're restricting your bottom end as you slow down the tractor as trying to adjust. So we want to keep it within that range if we can. So just as an example, let's assume we're putting down 10 pounds of granular chemical, or that's what we want to do. We need to know the size of our machine. That's the decal we're going to use. We need to know our target application rate, 10 pounds, and the speed that we want to apply it at. So this chart is based on 10 miles an hour. You use the equation on the bottom, and because it's based on 10, and we're assuming 10, which is the 1. So when we look at our roller configuration, a density of granular chemical is 40 pounds per cubic foot. So we're going to go third column from the right. We see the 50, and then the 40 is your pounds per cubic foot. Roll down to 10 pounds an acre, and we can see that it's in the range of a 25 mil roller. So now we know what roller we need to engage. The bottom chart is just for your product setup. All you need to remember is that at the same density and roller configuration, that number is 0.12. So we'll come back to that. So at this point, you go back to your roller, your metering system. You would block it out. You would engage or disengage drive screws as needed, and then you're basically ready to go set up your product. So back in the tractor, we're going to set up a product. Just a part of your configuration database. These save in your isobus or in the ECUs, so they're available to you the next time that you are ready to apply that product. We'll rename it, obviously, set your target rate, and then that 0.12, that calibration factor, we'll just use that as a starting point in your calibration process. So from here, you're going to go to your calibration screen, enter the calibration process. It's advised that you preload your rollers just to get an accurate result, and then it'll tell you to go back to your Procast machine, and you'll be set up much like this. It's a very simple process. You're going to set up your scale on the frame of the Procast, zero out your bag, put the bag underneath the meter, hit that green button, it'll start dispensing product, and then hit the button again when you want it to stop. We recommend that you try and fill the bag. Some low product rate stuff, you're going to maybe just wait a minute, and that's fine. So from there, you're going to measure the weight of the bag, and then punch it into the monitor, and the monitor will automatically adjust your calibration factor based on that value. I'd recommend doing it once more just to confirm if there's any errors in your test. If you're getting the same value twice, then there's no need to continue. And the last step is just to set your fan speed. So based on your size of machine, the type of product, and the rate that you're using, we've recommended some different fan speed ranges to use. That's just to get you started. And then once you've done this, you can set it into a simulation mode just to confirm that everything's operating properly. Simulation just tricks the monitor into a set speed that you're running at. You'd be sitting still. So I'm going to talk about some testing. I'm just going to briefly point out that the matrix or the Excel file on the screen there is just a guide. It allows us to evaluate our machine as good or bad, or what category it's in. But to do this, I'm going to explain one metric that this chart is based on, and that's called the coefficient of variation. It's essentially just a statistical method that is expressed as a percentage, which allows us to test different units, rates, or different units and scales. So a CV of 0, a coefficient of 0, means that every single seed run is the exact same. So lower is better, and 0 would be no variance whatsoever between each run. So I'm going to come back to this chart at the end in a summary, just to kind of show you where we ended up. So we did some testing with other machines in the market just to form a benchmark so that we could compare ourselves to a practical result. So in this case, we tested with 3 products. I'll start with wheat here. As you can see, our Procast is a 4% in the blue line there on average coefficient of variance, compared to a benchmark about 5.5. So we're doing well compared to an industry benchmark. Next, we tested radish, a bit smaller seed, a little bit different to work through the metering system. Again, we're noticing pretty decent results, averaging just over 4%. I should point out that the different trials, each data point is an individual trial that I've essentially averaged out to get these. And as you go from left to right, the rates are increasing. And lastly, I'm going to point one more result out here, or a summary of results with granular chemical. And this is where the Procast appears to have the best, or the biggest advantage over an industry benchmark, averaging just around 6% again, compared to 12. So it's about twice as good at delivering granular chemical with less variance. So just to summarize all that, I took all the results from the charts you saw there and I averaged them out. Procast versus benchmark, wheat, radish, and granular chemical were as good or better. And just to kind of show you where we ended up in that chart, we ended up in that satisfactory or sufficient stage, or sorry, I should say that sufficient stage for everything. And for a broadcast applicator, that's pretty good. Lastly, I'm just going to walk through some results just to kind of show you some fields that have been seeded with this product. It's hard to show granular chemical without doing like a weed survey, but I'll walk through some seeding. This is from our field just across the highway from us. It's our test field from last fall. And we seeded a 50 pound per acre cover crop with a bunch of different varieties in it. And this is how it looked. Seeded September 9th, looked a month later, and then over the next month took a couple more pictures. As you can see, by November, it's starting to turn brown and winter kill. So yeah, and then a couple more here. This is from Indiana. On the left, we have a soybean crop seeded by one of our farmers who's purchased a machine. On the top right is a cover crop mixture, very similar to the one we used in our test field much earlier on. And then on the bottom there is actually that same crop this spring after it's been winter killed, so the ryegrass made it through the winter. And lastly, these results are from Maine. I actually visited Maine earlier in May, and this was seeded about third week of May. Pictures from a week ago. This is a cover crop mixture including, like I said, ryegrass, clover, vetch, and winter peas. So as you can see, our farmers have had great results so far, and I'm very pleased to be presenting to you today. I'm going to hand this back to Derek to close out our presentation, and thank you for your time.
Yep. All right, thank you, Jordan. As you guys can see, a lot of time and development went into creating and perfecting the Procast, and we are thrilled to be standing at the launch pad here today at Canada's Farm Show to give you an in-depth look at this product. Farming operations are getting bigger. Every year it seems like they get bigger and bigger and they get more complicated. At Degelman, we truly believe in developing equipment that is easy to use and built to last. So if you guys have any questions, we're going to be hanging out by the machine for the next little while. Feel free to come over and we can walk through the machine with you. If you have any questions, we're here to answer them. In addition to our booth in the Affinity Agriplex building, stop by there. You can come see the first rock picker that Wilf Degelman built in 1962 out of his barn in Raymore. And you can also see the one that we pulled out of the bush and restored. Kind of a little bit of a cool piece of history here. And we have a Procast with a working monitor as well if you'd like to see how the system works there. And I'd like to just thank everyone for taking the time to come over to our presentation here today. Thank you to a lot of the dealer groups that we've had come in from Quebec and Ontario. Our US sales guys were finally able to come up to the show and see what's happening in the city that rhymes with fun. And so thank you again and have a great rest of the Canada's Farm Show.